second. I'm sharing my screen. Yeah. In the digital, we already seen the shift registers. Okay. So in the digital electronics, you already seen the shift registers, no? So what are those shift registers? So you have SISO, SIPO, PISO, PIPO. Okay, all those things. Okay. So that means shift registers. You have a shift registers. Okay. Yeah. Mm. So you have a shift registers. Yeah. Yeah. So in the shift registers, this mainly we are using D flip-flops in the shift registers. So you have the shift registers. What are the shift registers? Shift registers. You have SISO. Okay, SISO means what? Serial in, serial out. Okay, data will be sent serially, and data will be means loaded serially and taken out serial out. And next you have SIPO, serial in, parallel out. And next PISO means parallel in, serial out. And next you have PIPO means what? Parallel in, parallel out. Okay, SISO, SIPO, PIPO, PISO. Okay, these are the shift registers we already seen in the so basically first every each and every shift registers will see the Verilog code. Okay, suppose if it is first we'll see the SISO, serial in, serial out. Okay, serial in, serial out if you take, so how it will be there, like four flip-flops are there. Okay, four flip-flops are there. You have four flip-flops connected like this. This is a synchronous circuit. Common clock will be given to all the flip-flops. Okay, so here so data will be entered. So if you write, if you want to load four ones, common clock, this is passage of clock you are giving to this uh, the shift register. Okay, this is shift register. Common clock is given. Okay, and so basically what you are doing, you are using D flip-flops for all the shift registers. Okay, shift registers. And first, so you are writing. So first I will tell you for left shift. Okay, left shift. Okay, so I will tell you the logic for left shift. Suppose suppose initially the content of all the registers, let us take the content of all the registers are like 0 only. Okay, content of all the registers are 0 only. So these I'm storing in a temporary register. Okay, these I'm storing in a temporary register. So serially I want to enter the data. Okay, so that is nothing but serial in. Okay, serially I need to load the data. Okay, so first, so that means this is at 0 clock cycle. Okay, 0 clock period, first initial condition, the output of all the registers are 0 only. At first clock period, what happens? This will be loaded. So that means one will be loaded, and this will be shifted. Okay, this will be shifted like this. Okay, so one will be loaded and this will be shifted. Okay, so what is the logic over here? So here you are shifting means so at first clock pulse this will be shifted. So that means here this 0 will come here, this 0 will come here, and this 0 will come here. Okay. At second clock pulse, what you are doing? That means this will be shifted. So this 1 will come here, this 0 will come here, and this 0 will come here, and whatever the vacant position is there, that will be loaded with the 0. Okay, vacant one position is there. So sorry, I want to load four ones. Okay, I want to load four ones means here next data, bit by bit I'm loading the data. Okay, at third clock pulse, what happens? This will be shifted. Okay, this will come here, and this will come here, and this will come here. 0 will come here, and again one more one. Okay, from here one I'm loading the data. Okay, at fourth clock pulse, what I'm doing, I'm shifting this. Okay, this one will come here, and this one will come here, and this one will come here, and here I'm loading the data. Okay, So basically, like so 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 this is the shift operation I am doing. Okay, so that means so if you draw the seesaw, so it will be like this. This is serial in, serial out, serial in, serial out. You have a clock, and you have a reset. Okay, and there is serial in data, serial in data. Okay, and next there is a serial out data, serial underscore out. Okay, so this is one bit only, serial underscore out, and this is also one bit only. Okay, this is also one bit only. Okay, so like this you are shifting and you are taking out the data. So at fifth clock pulse, what happens again? This will be shifted. So you are getting 1 and 1 1 0, and at sixth clock pulse you are getting 1 1 0 0. Okay, at seventh clock pulse you are getting 1 1 1 0 0 0. Okay, like this at eighth clock pulse. At eighth clock pulse you are getting all the data out. Okay, so the logic behind is this one, SISO is second. Yeah, logic behind is, suppose I can use for left shift. Here I am doing the shift operation. No? So that means this is nothing but like serial in data. Okay, these 4 bits are there. No? So this is nothing but serial in data, serial underscore in. Okay. Here, what I will do. So first, so this is the index value 3210. Okay. So that means initially the values are 0000. Okay. After that, so these values are there. No, these values are shifted. Okay, these values are shifted. Okay, that means these values are coming here, and one more data is loading. Okay, so this is at first clock pulse. At second clock pulse, what happens? These values are loaded here, shifted. Okay, so that means 001, and one more data is loaded. Okay, at third clock pulse, what happens? These values, okay, whatever these values, 0 g, these are shifted. Okay, 0 0, sorry, this is 0 0 1 1 and 0. Okay, and next at fourth clock pulse, what happens? At fourth clock pulse, these values, what are these values? These values are loaded. Okay, 1 you are loading, and 1 1 1 and remaining 1. Okay, so that means I can write what I can write oh, what I can write is, here I'm using a concatenation operator. temp equal to temp equal to temp temp this is what 2 down to 0. Temp 2 down to 0. Okay, this is nothing but temp 2 down to 0, comma, every time your serial in data is you are inserting. Okay, so that is nothing but serial underscore in, serial underscore in. Okay, so this is the left shift operation. Okay, so this is the logic behind left shift operation. You need to use the concatenation operation. Okay, you need to use the concatenation operation. Okay, so hope you understood this one. Okay, so I want to write the program. So how we are writing the program? So like module SISO, 4 bit. This is the identifier. Okay, and input clock, input reset, and input serial underscore in. Okay, and output serial underscore out, serial underscore out. Okay, so this is declaration of my input and output. Okay, after that I need to initialize one temp register. So that means reg temp register is how many bit? 4 bit. 3 down to 0 temp, 3 down to 0 temp. Okay, next so begin. Okay, uh, if reset. Okay, or we need to use the behavioral modeling. No, I'm using always at the rate I'm using active low, that means asynchronous active low reset. Okay, passage of clock or negate of reset. Passage of clock or negate of reset. Negate of reset. Okay, begin, begin. If not of reset, if not of reset. Okay, so not of reset. What I need to write? Temp equal to what? Temp is initialized to that value. That is, it is initialized to 4 tick binary 0 0 0 0. Okay, and else I need to write the condition. That is temp. Temp is non-blocking operator. I need to write temp 2 down to 0 comma serial, serial underscore in. Okay, so this is for which operation? Left shift. Okay, left shift. Okay, and end, end, and next end, and next what I can write after end, and I'm using continuous assignment statement, assign, assign serial out, serial underscore out, that is equal to what? So I need to get one bit, no? So where I'm getting the data? I'm getting the serial out data at which bit? That is third bit I'm getting. That means what? Temp 3. Temp 3 I'm getting. Okay. So one bit I'm loading the data. After loading the data, I'm shifting one bit. Okay. So I'm getting 4 bit of data at a temp 3. Okay. This is nothing but temp 3. Temp 3 and end module. End module. Okay. So if it is a right shift operation, what you can do? Suppose initially these all are 0 only. So 1, 2, 4, 5. Okay. So you are loading from left. This is shifting right. Okay. So first clock pulse, what you are doing? You are loading, no? So first, this is 0 clock pulse. First clock pulse, you are loading 1. Okay. And whatever this, okay, 1, 2, 1 second. These are the 0, 1, 2, 3. Okay, 1 second. These are 0, 1, 2, 3. Okay. So that means these are shifted. Okay. So this will be loaded and these are shifted. Okay. And at second clock pulse, these are shifted. Okay. So that means you are getting 1 0 0 and 1 will be loaded. At third clock pulse, what happens? These are shifted. Okay. So 3 down to 1 are shifted. Okay. 1 1 0. Okay. 1 will be loaded. At fourth clock pulse, these are shifted. Okay. 1 1 1 and 1 will be loaded. Okay. At fifth clock pulse, again this will be coming into the temp 0. Okay. This will be coming into temp 0. Okay. Sixth clock pulse, you are getting 0 0 1 1. At seventh clock pulse, you are getting 0 0 0 1. Okay. At seventh clock pulse, you are getting all the bits. Okay. So what I can write in the right shift? What I can write in the right shift operation? So this I can write. That means temp, temp is less than or equal to, okay, non-blocking operator. So that means serial in. Okay, from left you are inserting the data. Serial underscore in, comma. What operations will be copied? Temp, temp 3 down to 1. Temp 3 down to 1. And next, at last, you need to write assign, assign serial out, serial out equal to what? You are getting the serial data at temp 0. You are getting the serial data at temp 0, no? So temp 0. This is for which operation? Right shift operation. Right shift operation. Okay. Right shift operation. Okay. So like this, you need to write the program for what? SISO. Okay. I'll show you the program in the Xilinx Vivado SISO program. One second. Yeah, this is shift operations. Okay, this is the shift operation. So I wrote the program for left shift. So I wrote the program for left shift. So SISO left shift. Okay. So module SISO left shift, and next whatever the inputs, input is clock and input reset, and input is D in. Okay, there I consider serial in. No, here D in, and output is D out. I'm initializing one temporary register reg 3 down to 0 temp. Always at the rate passage of clock or negate of reset. I'm using what asynchronous active low reset. Begin if not of reset. Okay, temp equal to what I need to clear the output of all the flip flops. Else, temp is initialized to temp down to 0 D in. This is left shift operation. And after completing this behavioral modeling, I need to use a continuous assignment statement assign D out equal to temp of 3. This is output bit and end module. Okay. And next, I wrote the TB also. Okay, TB for left shift. So in the TB, so module TB CISO left shift, okay, and whatever the input variables are there, that I need to initialize with reg data type, and whatever the output variables are there, that you need to initialize with y data type. I need to instantiate. Okay, here I am using connection by position only. So how we are giving the inputs, how we are declaring the inputs, that I need to declare. Okay, basically we need to go for connection by name only. Here I indicated connection by position. Okay, and always clock generation. Always clock equal to what? Not of clock. So this is clock generation. Initial begin. So I'm making clock equal to 0, and here I need to make I need to deassert the reset. No, reset equal to 0 and in equal to 0. Okay, and after that I need to assert the reset. Okay, I need first I need to assert the reset, and next I need to deassert the reset. Okay, apply the reset for. So I'm releasing the reset. Okay, going into functional mode, and I'm giving the text vectors. Okay, 1 1 1 1. I'm giving. I'm waiting for 30 time units, and after that I'm finishing the simulation. Okay, so this is CISO. So I want to run this simulation. Right click, set as stop. Right click, set as stop. Run the simulation. Run behavioral simulation. Save this. Yeah, I got the simulation. You see here. Just fit to page. During the reset, okay, during this negative, that means when reset equal to 0, the output will be 0 only. Okay, so when reset becomes 1, okay, during this state, okay, when reset is deasserted, what happens? Immediately you are not getting the output. What happens here? During the passage of clock, you are getting the data. Okay, initially what you are doing, you are giving all the inputs. Okay, 1 1 1, you are giving all the inputs. Okay, 1 1 1, you are giving all the inputs, and after that this is serial in. Okay, during 4 o'clock pulses, serial in data is happening from 10 to 40 time minutes. After that serial out data is happening. Okay, or in order to see in the test bench, you change the values. Okay, suppose in the test bench I am giving what values, 1010 I'm giving. Okay, 1010 I'm giving. Okay, just to save this, and run the simulation, run behavioral simulation. Yeah, I got the waveform. Fit to page. Okay, fit to page. See here. So during, that means here during the passage of clock only, like shifting, loading operation is happening. Okay, loading operation. 1 second, you are getting the out. Okay, Dean here during loading operation, you are not getting any D out. Okay, this is nothing but what, loading operation. Okay, you are loading the data into the shift register. Okay, so when you are loading the data into shift register, you are not getting data output. So when you are getting during next clock edge, okay, next Next, after loading is happening, and next data you are getting. Okay, you are getting 1010. Okay, so from here you are getting 1010. Okay, so this is SISO. Okay, serial in, serial out. Okay, and next we'll go with next one is uh, next one is that is right shift and left shift. Okay, and next we'll go for SIPO. Okay, serial in, parallel. Okay, SIPO. So if you see the SIPO, serial in, parallel out. Uh, so that is SIPO, serial in, parallel out. Okay. So that means serial data in. For serial data in, it will take how many clock cycles? It will take 4 clock cycles. Clock cycles. For parallel out, it will take only 1 clock cycle. It will take 1 clock cycle. Okay. So basically, like you have, so like this module will be there. So this is my SIPO, and you have clock. You have clock. Next reset and serial in, serial in, and there is load also. Okay, and there is one thing, that is load. Okay, or we have like in SIPO we already seen shift by load bar, shift by load bar. Okay, shift bar by load. Okay, shift bar by load you seen. Okay, so that means when shift by I think shift by load bar we already seen. Okay, that means if shift bar by load means what? This is active low signal. So when this is if you consider shift bar by load, so when it is 0 it will do shift operation. Okay, when it is 1 it will do load operation. Okay, first you need to do the load operation. Okay, so let us take the input is load. Okay, so that means when load equal to 1, the data will be loaded into this SIPO. When load equal to 0, that will be shifted. Okay, that will be like parallel out you are getting. Okay, so parallel out data, you have parallel out data. Parallel out means this is how many bit? This is 4 bit wide. 4 bit wide. Okay, 4 bit width. Okay, so how to write the Verilog code? So here, so first module, SIPO, module name, and input clock. Okay, input clock. Okay, input clock, and next input reset, input serial in. Okay, serial in. So here what is happening? That means if you do the left shift, if you want to load like 4 ones, if you want to load 4 ones, okay, left shift operation means from the left you are loading the data. So there is a temporary register. Initially the temporary register is what when you are applying the reset, it will be 0 only. After that, so you are loading from left. First clock pulse, it is 0 clock pulse. First clock pulse, second clock pulse, you are loading the data, and third clock pulse, next you are loading the data, and fourth clock pulse, loading and shifting is happening. Okay, you are loading the data. Okay, fourth clock. That means at fourth clock pulse you are taking out all this parallel out, parallel out. Okay, so that means here the logic is same as ISO only. Okay, so that means left shift only. Okay, serial in, and next input, not input, output. Output is what? Output 3 down to 0, 3 down to 0, parallel out, parallel underscore out. Okay, so I initialized. Okay, and next I want to do always at the rate passage of clock or neck edge of reset, neck edge of reset. Okay, so begin, If not of reset, okay. Temp equal to what? Temp I need to initialize with 4-tick binary 0000. Okay. Else temp is initialized to uh, temp 2 down to 0 comma serial underscore in. Okay. And after that end. Okay. Here so begin end assign parallel underscore out. Okay. Is temp. 4-bit of data should be come into parallel out. Okay. End module. Okay. So this program, this is nothing but SIPO, no? So SIPO I will show you in the Xilinx Vivado. So I'll close this and SIPO. Okay, this is SIPO. Same thing, whatever the program I wrote. One second. Yeah, this is SIPO. So same thing, whatever I told. So here in terms of serial in, I'm taking D in and serial out is D out. Okay. So that means here I can use neg edge of reset. Okay. Neg edge of reset and not of reset. Not of reset. I'm initializing. Else shift ridge. Okay. That means here I can use temp or shift register. Okay. Shift ridge also same thing. That is whatever your wish. So shift ridge 2 down to 0 comma D in. This is nothing but loading the data and assign D out equal to what? Shift ridge. Okay. And I need to write the test bench. No, I need to write the test bench. Okay. So this is the test bench module TB. What is this? SIPO. Okay. Reg clock. Whatever the input variables are there that I need to initialize with reg data type, and output are there that I need to initialize with the wire data type, and I need to instantiate with connection by name. Okay. So whatever the output are there, those are nothing but design variables, and inside the bracket are nothing but test bench variables, and I need to generate the clock. Okay. Always hash by clock equal to not of clock initial begin and clock equal to 0. I need to make reset equal to 0. When reset equal to 0, d in equal to 0, I need to deassert the reset. Okay. And after that, I'm giving some values. Okay. D in equal to 1111. And after 20 time minutes, I'm finishing the simulation. Okay. So this one I need to make as top module, set as top SIPO. Okay. And run the simulation, run the behavioral simulation. Here you see. So fit to page. Okay. Yeah, what happening? Mm, 1 second. Yeah. See here. That means first during this that means uh, 1 second. 1 second. In the test bench. 1 second. I'm closing this. This is which one I'm PISO you are taking? Okay, sorry, PISO. This is PISO. Okay, PISO I need to take as top model. PISO. Okay, PISO. Uh, PISO or SIPO? SIPO. Second, SIPO. This is SIPO. Data stop. SIPO. Run simulation. Run behavioral simulation. Yeah, first what I am doing here serial in parallel out. No, serial in parallel out means first serially I'm loading the data. Okay, serially I'm loading the data. After that, parallelly I'm taking out the data. Okay, I can take parallelly. I can take out the data. Okay, this is SIPO. Okay, SIPO. Okay, and next PISO. PISO means what? Parallel in serial out. Okay, so parallelly you need to load the data. Okay, and serially you need to take out the data. Yeah, yeah. At last, we will see. Okay, PISO. Okay, next PISO you see. One second. PISO. PISO. PISO means what? Parallel in serial out. Okay, so parallel in serial out means here clock, next reset. You have load. Okay, load means what? So when load equal to 1, you have load operation, and when load equal to 0, you will get shift operation. Will get shift operation. Okay, and this is parallel in, parallel underscore in. Okay, and this is serial out, serial underscore out. Okay, and this is PISO, parallel in serial out. Okay, so this is what 4-bit. This is what 4-bit. Okay, so here what you are doing, this is my design, and here 3 2 1 0. Okay, first what you are doing, parallelly you load the data. Parallelly you load the data. After that you are shifting the data. Okay, you are shifting the data, so that means this will go. Okay, serial out, this will go, this will come to the serial out, and here you'll get 1 1 1 0, and after that this will be shifted, you will get 1 1 0 0. Again this will be shifted 1 0 0 0, and this will be shifted, you are getting 0 0 0 0. Okay, so that means I can write the logic. So that means every time this is copied. See here, every time 1 1 is copied here, 1 1 0 next 1 1 1 is copied, where it is copied, one second. 1 1 1 is copied, and next this one will be shifted. This 1 1 0 is copied. Yes, see here 1 1 0 is copied, and next 1 0 0 is copied here. 1 0 0 is copied here. Okay, like that, and next this one is copied here. This one is copied here. Okay, so from this I can write the logic. Temp is non-blocking of temp, temp 2 down to 0, 2 down to 0, comma, whatever the new vacant position is there, that will be loaded with what? 0. New value is there, that will be loaded with 0. Okay, so here how I write the program: module, module, PISO, PISO, input, input clock, input reset, and input reset, input, you are loading the parallel data, no? 3 down to 0, parallel in, parallel in. Okay, and next input, input load, and output, output serial underscore out, serial underscore out. Okay, this is the initialization. Okay, and next I need to initialize reg some temporary register, 3 down to 0, temp, temp. Okay, and next always, always at the rate passage of clock or negate of reset, negate of reset. Okay, if not of reset, if not of reset, temp equal to what? Temp is initialized to 4-tick binary 0 0 0 0. Okay, else, else, next if load. Okay, if load, okay, if load equal to what? Load operation. If load equal to what? Load operation. Okay. So that means if load equal to 1, that means what? If load, okay, load operation. That means what? Temp is initialized with what data? Parallel underscore in. Parallel underscore in. Else if load equal to 0, load equal to 0, okay, temp equal to what? Temp is initialized to temp 2 down to 0 comma 0, 2 down to 0 comma 0, and okay, after that you need to assign serial underscore out. Okay, where you are getting the serial data? At temp 3, no, you are getting the serial data at temp 3. Okay, so this is my temp register. This is my temp register. Okay, you are getting the serial data. Serial out is assigned to temp 3, is assigned to temp 3. Okay, and end module. Okay, this is my code. Okay, I'll show you code in the Xilinx Vivado. So here, which one? PISO, no? Which one? This is PISO. Okay, so this is PISO code. Okay, so initially, so module PISO, input clock, input reset, input load, input 3 down to 0 D in, and in place of that, I'm using D out. Okay, that is parallel out. No, for parallel out, I'm using D out. So this is serial out. Okay, this is parallel in. Okay, parallel in, and for temperature, I'm using shift register. Okay, if passage of clock and negate of reset, if not of reset, I'm clearing these values. If load, okay, if load, I can use D in also. Okay, I can use D in also. Okay, this is parallel load operation. 4 bits of data I'm loading. Okay, here I think I can give D in also. Okay, 4 bit of data, no, so 4 tick binary, this is 4 bit of data. Else shift ratio equal to what? Shift ridge of 2 down to 0 comma 1 tick binary 0. Okay, shift left, insert 0 at LSB. Okay, end, and always at the rate star d out equal to shift ridge of 3, and end and end module. Okay, end and end module. Suppose here I'm not using reg. Okay, here I can use what? I can remove this, and here also I can remove this. I can use continuous assignment statement, that is what? Assign. Okay, I think it will take assign d out equal to what? D out equal to shift to reg of 3. Okay, I can use like this also. Okay, just copy this save this, and coming to the test bench. uh, so we are doing PISO, no? PISO. Okay, so PISO, here what I am doing, whatever the input variables are there, that I need to initialize with reg data, clock, reset, load, and d input 3 down to 0, wire d out, and connection by name. Okay, and I'm generating the clock, and clock equal to 0, and first I'm assetting the reset. Reset equal to 0, load equal to 0, d input equal to 4 tick binary 0, and I'm deassetting the reset. Reset equal to 1, and after that, load equal to 1 means what? I'm loading parallel data, that is 1 1 1 1, and after that I'm making load equal to 0. That means this is parallel load. Okay, parallel load equal to 1 means parallel load. After that, I'm making load equal to 0 means serial shift operation, and I'm observing for 50 time minutes, and after that I'm finishing. That means dollar finish means I'm stopping this simulation. Okay, so this one I need to set a stop. Okay, PISO, run simulation, run behavioral simulation. Save this. Yeah, see here what I am getting. Fit to page. First, when reset equal to 0, so you're not getting anything. When reset is deasserted, during this edge, Okay, so here load is equal to load becomes one means what loading the data. Okay, you are loading the data. Okay, you are loading the data. After that you are doing shift operation. Okay, you are loading the data F. Okay, here till here you loaded the data. Load equal to 1. After that you are shifting the data. So here when you are doing shift operation, you got this F values. Okay, during this you are shifting the data into D out. Okay, you can see the D out also. Okay, loading the data and shifting the data. Okay, you are getting D out here. So here you are loading the data, you are shifting the data. Okay, so this is SIPO. And next PISO is simple, no? PISO means sorry, PIPO. PIPO means just you load 4 bit of data and you take out 4 bit of data. Okay, so this is PIPO. Module PIPO, input clock, input reset, input 3 down to 0 T in. So parallel input and parallel output. Okay, output 3 down to 0. Okay, parallel input and parallel input is 4 bits and parallel output is also 4 bit. Okay, and I'm using this temp register, no, temp register, that is register data. I'm initializing with 3 down to 0. This is 4 bit. Always at the right passage of clock and negate of reset begin. If not of reset, okay, clear the content of all the registers. Else reg equal to what? All that data will be loaded. Okay, all that data will be loaded. Okay, so that means data out equal to what? Data register equal to, so within one clock cycle the parallel loading operation and parallel input loading and that taking out the data will be happening. Okay, and whatever the reg data is there, you are assigned to D out. Okay, this is nothing but PIPO, parallel in parallel out. Okay, parallel in parallel out. If you see the test bench, we see the test bench. One second. One second. PIPO. Module TB PIPO, reg clock. So whatever the input are there, you need to initialize with reg. Output are initialized with wire and connection by name. Okay. Output variables are design variables and input inside the bracket are nothing but test bench inputs. Okay. And generating the clock always #5 clock equal to not of clock and initial begin and you are deassetting the reset. When you are assetting the reset, d in equal to 0 and you are deassetting the reset. Deassetting the reset. And after that, what you are doing, different parallel inputs you are giving. For 10 time units, you are giving 1010. So this is nothing but A. After 10 time units, you are giving 1100. Okay. So that is you are giving C. Okay. And next after 10 time units, you are giving 0111. This is 7. And after 20 time units, what you are doing, you are finishing the simulation. Okay. So this is the test bench. Just right click, set as top, set as top. It will be assigned to top module. Run simulation, run behavioral simulation. Save this. Save this. So here you see set to top, set as fit to page. See here parallel. There is a parallel input. Okay, parallel input data. Okay, during reset. Okay, when reset equal to 0, output will be all the zeros only. Okay, input and output all the zeros only. Okay, during the negate of clock only. See here during this clock. So what happens? So parallel load operation is happening during this passage of clock. Parallel output you are getting. Okay, parallel whatever A is there you are getting, and here you see. So during the passage you are getting this C, and during this passage you are getting 7. Okay, whatever the inputs are there you are getting at the outputs. Okay, so this is nothing but PIPO. Okay, so today's session we discussed about CISO. Okay, in CISO we already seen left shift, right shift, what is the logic, and SIPO, serial in parallel out, and parallel in serial out, and parallel in parallel out. Okay.